Mariana, you just asked me a question.
Yes, 2.
Number
2.
2. Explain the following statements. A substance that acts as an oxidizing agent gains electrons. What does an oxidizing agent do? By definition, an oxidizing agent does what to another substance? It oxidizes it. Yes?
Yes.
Okay. So if I'm an oxidizing agent and I oxidize you, what happens to you? You lose electrons. If I oxidize you, you lose electrons. Yeah? And so what happens to me? I end up gaining electrons. A substance that acts as an oxidizing agent gains electrons. Yeah? There are other ways to say it, but that's the idea.
We just like rather true, or?
Well, you're supposed to explain that. I just did. An oxidizing agent oxidizes another substance. In order to be oxidized, that substance has to lose electrons. So an oxidizing agent must take electrons away from something. That's a different explanation. It means the same thing. B, we live in an oxidizing atmosphere. What is it in our atmosphere that does such a good job of oxidizing things? That's right. That's right. And we're fortunate that we only have about 20% oxygen in our atmosphere. Now, not that it could really be anything different than that, but we're fortunate. What would happen if our atmosphere was 100% oxygen?
We would die.
Well, yeah, we'd have problems with oxidation, wouldn't we? The higher concentration of oxygen would make oxidation reactions occur that wouldn't ordinarily or easily occur. For instance, we've lost some astronauts over the years, haven't we? We lost the crew of the Challenger, we lost the crew of the...
Apollo 12.
No, well, I was going to do Apollo. We lost the crew of the other shuttle. Which one was that? The Enterprise? Which one? One of them
Wasn't that
was
from
the
Star
Enterprise.
Trek?
Really? Yeah.
The Enterprise, Discovery, Challenger.
I'm pretty sure Challenger and Apollo 12 were the only bad things that happened.
No.
No, because there have been a couple.
We had the last accident was the space shuttle that had a hole knocked in the insulation on the wing, and it disintegrated on re-entry.
No, Challenger was the chill.
Challenger was one that blew up.
Oh.
Challenger had the 2 solid rocket boosters that are used to add additional thrust are bolted onto the large tank that contains liquid hydrogen and oxygen, which is used in the main engine of the shuttle. And there was a leak in an O-ring in the solid rocket booster, and a tongue of flame shot out after when the solid rocket booster was ignited, and it burned a hole in the tank full of hydrogen.
Oh, just blew up.
That was bad. But the one I wanted to talk about was Apollo 12.
Good movie.
Apollo 13 was the movie.
Can anyone tell me who the commander of that mission was? Apollo 12. No reason that you should know. His name was Gus Grissom. He had been up before as an astronaut. He and his crew, there were 3 of them. The Apollo missions had a capsule with 3 people. The Apollo missions were ultimately designed to take men to the moon and succeeded. They were on the launching pad doing pre-launch tests. The launch was a couple of weeks away, and they were running through a dry run. They had got their suits on, were inside the capsule, and doing some practice runs. And at the time, they used a pure oxygen atmosphere in the capsule. There was a reason for that. If you're breathing pure oxygen, if something bad happens and you lose oxygen in the capsule, because you're breathing pure oxygen, you have a few seconds more to stay conscious before you lose consciousness. And in that few seconds, you may be able to remedy the situation. That's one of the reasons they use pure oxygen. The problem is that in pure oxygen, there are things that burn that wouldn't ordinarily burn, like the insulation on the wires that they used in the electrical wiring. And there was a sudden surge and a spark, and it ignited things inside the capsule, and the 3 of them in a matter of 90 seconds burned to death.
Oh, God.
It was the first death as part of the NASA space program.
Because you can't open the doors.
The door is bolted shut, and they would not have had time to do any of that. They would have been overcome by flames before that happened.
And that was on Earth, right?
They were on the launching pad. The rocket was not fueled. It was in its position. They used a Saturn V rocket at the time, but the liquid fuel was not in the rocket. You know, they were a couple of weeks away from launch.
And then you get off.
Yeah. Now, the reason why I remember the name, is there anyone here who plays hearts?
Sure.
Okay. You know, in hearts, the game is to not take hearts, right? And there are points, there are cards in the deck that are points. Each heart is worth 1 point, and the Queen of Spades, sometimes called Dirty Dora, sometimes called the Bitch, because she's worth 13 points. And in this game, you don't want to take points, unless
You get all of them.
you can take all of them. If you can take all 13 hearts and the Queen of Spades, then instead of you losing 26 points or gaining 26 points, which is bad, your opponents all gain 26 points. It's the best thing that you can do in hearts. It's called shooting the moon. Well, among a group of friends of mine who like to play hearts a lot, the worst thing that can happen to you is to have you take only 12 of the hearts and the Queen of Spades. Because then you get 25 points. And my friends called that the opposite of shooting the moon. It was called the Gus Grissom. Dark humor, dark humor. And all of that because the question asked, we live in an oxidizing atmosphere. 2C, an atom in its elemental form has an oxidation number of 0. Isn't the oxidation number kind of keeping track of electrons lost and gained? Kind of. And something in its elemental form has neither gained nor lost electrons, huh? If it had gained 2 electrons, we'd say it had an oxidation number of -2. If it had lost 3 electrons, we'd say its oxidation number was +3. But it has neither, since it has neither lost nor gained electrons, we say its oxidation number is 0. Now, I said that the oxidation number is kind of keeping track of electrons lost and gained, because we also use oxidation numbers when we have covalent bonds, when atoms are sharing electrons but not equally. So it's kind of electrons lost and gained, but not really when we're talking about covalent compounds. So, because that's kind of complicated, we sort of don't talk about it much. But we have rules for assigning oxidation numbers, don't we? Okay? And finally, 2D, we would expect the elemental form of a nonmetal to be reduced rather than oxidized. What do we expect nonmetals as elements to do?
They want to fill their shells.
Gain electrons to have full shells, right? And gaining electrons is reduction. So we expect metals in their elemental forms to be oxidized. We expect nonmetals in their elemental forms to be reduced. We expect that. It's not always true. True that metals are always oxidized, but not true that nonmetals are always reduced. Depends on what, for instance, if we have a nonmetal like nitrogen, and it bonds with a nonmetal like oxygen, the oxygen ends up being reduced. The nitrogen ends up being oxidized. That was number 2. I know, it took a long time.
Number 5.
Number 5, which of the following is not an oxidation-reduction reaction? Well, we can assign oxidation numbers to everything, can't we? And if the oxidation number changes when you go from one side to the other, that means it's either gained electrons or lost electrons, which means it's either been reduced or oxidized, right? But we had a little hint, didn't we? If you see something in its elemental form on either the right or the left, then it must be an oxidation-reduction reaction, huh? Because if it's in its elemental form on one side, it has what oxidation number? 0. And on the other side, it can't have 0 as an oxidation number.